So this is the last chapter on mechanics. The last lesson on mechanics, well, M2. I know a lot of people don't like mechanics, and I'm going to end the torture by the end of this lesson. Right, so 8.4, 8.5, we're still working vectors with calculus. So last lesson we did, remember we were working on calculus with Schubert. So distances, velocity, acceleration. So everything sort of worked in the same way. A bit of recap from last lesson. Now, this lesson, when we look at vectors, we can describe instead of using distance, we can use position. So everything sort of works the same way, but position, we use the letter R to represent it. Okay, so velocity, we still have velocity. So we're going to repeat the same diagram, but this time we just have the position instead. So acceleration, we have A. Now, if remember going down, that will be V equals dr by dt. This time it's dr by dt because it's position. So R. This one is A equals dv by dt. Going back up, that will be V equals integral of A dt. And then going back up, we have R equals integral V dt. So going down will be differentiation. Going up will be integration. So we know that. Now, just one more thing, which is the difference between position and displacement. Position is using I and j like coordinates. You can describe position relative to a point using I and j. 3i plus 4j will be 3 to the right and 4 upwards. So how do we differentiate that then or integrate? Well, if r equal xi plus yj, okay, then v will equal dr by dt, and therefore v equals to, you differentiate x over ti plus differentiate y over t with respect to t, j. So essentially what we do is we differentiate x and differentiate y separately, I and j. Okay. Sometimes people might also write so as x dot I plus y dot j. The dot here means it's the first derivative. Okay, means it's differentiated. So yeah, everything sort of works the same way. So we'll see how it goes. Example, a particle P of mass 0.8 kilogram is acted on by a single force F Newton relative to a fixed point origin. The position vector of P at time t seconds is given R meters, where R equals 2ti cube I plus 50t to the power minus a half j. You see this, asks you to find speed, acceleration, you know something to do with calculus. Okay, so find the speed. Speed means v. So to find v, I need to do v equal. To find the formula that starts from v equal, you only got two options. V equals dr by over dt, or v equals integral of a dt. We know it's not the second one because we're not given acceleration. So v equals dr over dt equal, so differentiate 2t cubed, that's going to be 6t squared, I plus or minus, multiply 50 by minus a half is 25, so minus 25 t to the power of negative 3 over 2 j. It's differentiation, so there's no child needed. So we're child 3. When the time is 4, so let's put in time equals 4. When t equals 5, or t equals 4, velocity equals 6 times 4 squared I minus 24, 5 times 4 to the power of minus 3 over 2j. Plug in the calculator, you should get v equal to 96I minus 25 over 8j. But that's not the speed, is it? Speed is the Pythagoras, the magnitude of velocity, to do 96 squared plus 25 over 8 squared. And then you will get 96.1 meter per second, and that's the speed, right? Part B, find acceleration. Guess what? How to find acceleration? A equals to dv by dt. So we differentiate v. So we got our v from the question before, which is here. So we got our v. So we can differentiate v. So 6t squared differential will be 12ti, and then plus 75 over 2t to the power of minus 5 over t, 5 over 2j. That's meter per second squared. To find acceleration at 2 seconds, when t equals 2, a equals to 12 times 2i plus 75 over 2 times 2 to the power of minus 5 over 2j, which equals to 20, 24I plus 6.63J meter per second squared. So, sir, why don't we have to find the magnitude? Because the question didn't ask for. The question for acceleration. So, but to play safe, you can also work up the magnitude as well, just in case. But they didn't ask for it, so I just leave it like as a vector form. If they do need your acceleration magnitude, they will ask you for it. But it never, it's never a wrong thing, harmful thing to work out a magnitude as well, just in case. So in this case, I will do that. So if you do in case, so just in case, you never know what the question needs, I'll just put it next to it. Okay. Right. Part C. Find F when t equals 2. Well, F, there's only one and the only one formula about force you have learned. F equals ma. Well, so they want you to do, to find F, you need F equals ma. Have we got a mass? Yes, we do. 0.8 kilogram. Have we got acceleration? When t equals 2. So we found the acceleration when t equals 2 in part B. So we've got that. So F equals ma. So we can do F equals the mass 0.8 times the vector of A, 24 and 6.63. Or you can do F equals 0.8 times the 24.9. Depends if you have found a vector form or not. If you haven't, then multiply in, you get 19.2 and 5.30. So F equals to 19.2I plus 5.30J. They didn't ask for magnitude, but if you need the magnitude, you can do the Pythagoras thing using the 19.2 and the 5.30. But in here, if you plug it in, 0.8 times 20, 0.8 times 24.9 is 19.92. So if you try to put that 19.2 squared plus 5.3 squared in the calculator, yeah, you get a similar answer. If you try and work on magnitude of F, you will see that's the same, right? So they didn't ask for magnitude, but might as well, right? Hopefully it's a bit straightforward. In an example, a particle P moves in a horizontal plane, and R is given like that. So when t equals 2, the speed of P is 60 meters per second. Now, this is what we call a boundary condition. So we can say when t equals 2, v equals 16. So that's going to be useful information. Now, I haven't seen the question. I know something to do with maybe working out a c value. Let's see if I'm correct. Find the value of k. So where's k? K is r. We're given speed, but we'll find k. We'll find displacement. So how do we do that? Well, v equal. So we're not technically given v, but we do want to find out v because so we can use the speed. So part A. So v equals dr by dt. So dr by dt. So dr by dt. So v equals, differentiate the first term, first bracket, with 20 minus 60 squared I plus 2k tj. When t equals 2, the speed is 16. So speed, well, actually, what about when t equals 2? So let's put in 2 first. When t equals 2, let's put in. So v equals 20 minus 6 times 2 squared I plus 2k times 2j. Simplify that, you would get minus 4i plus 4kj. So speed equals to the square root of minus 4 squared plus bracket 4k squared. A lot of students would have forgotten the k in the bracket, so make sure you square that k as well. It's a whole j component squared, and I know that's equals 16. So actually, I was wrong. So this is not about integration yet. Square on both sides. So minus 4 squared is 16. So 16 plus 16k squared equals squared of 16 is 256. Simplify the algebra, you can see in here is just 16k squared equals 240. So k equals divided by 16 square root plus root 15 or negative root 15, because we know always come to square root with plus and minus. But which one do we need? Is it plus or minus? The question says k is a positive constant, so we'll reject that now. Okay. Right. Part B. Find the acceleration of P at the instant when it's moving parallel to J. Now, in the rover, it's all about R, B, and A. When it says moving parallel to J, which component does it relate to? Okay, moving parallel to J. Now, first of all, we know it's nothing to do with acceleration because they want to find acceleration. So A is out of the equation, out of the choices. Now, I think we do mention something similar before in 8.1, 8.2, when we mentioned due east of something. Now, when you say due east of something, you're describing the position because you say you're due east of a point, so that's a position. But when you're moving parallel to J, then it's something to do with velocity. Okay. Now, moving parallel to J means, so that means the particle is, so J is like a y-axis. Moving parallel to J means you're moving in a straight line upward like this. In other words, this V will be something I plus 0J because you're just something like, no, sorry, actually, sorry, I was wrong. It should be there around. So y-axis, it should be, oops. It should be V equals to, yes, 0 I plus something J meter per second. So that's what it means. So part B, moving parallel to J means the V equals, now it's moving parallel, so we underline V just to mention, so you can use whatever way you want to use highlighter to make to tell yourself why is it V not R. You can write a little note next to it. Why not R? Okay, because R describes position, so you can say due east, due, then use R. Moving, use V. Parallel to J means 0 I plus something J meter per second. The question is what's the J value in here? So on the other hand, what we know is the I component of velocity equals 0. So what's the I component of velocity? Well, the I component of velocity is this one. So V equals 20 plus 6 minus 6t squared. Therefore, 20 minus 6t squared equals 0. And if we work it out, you get t equals to square root of 10 over 3, which you can get a full value, but you know. So the I component of velocity equals 0. What else do we want to find? Do we need to find velocity? Well, the question did not ask me for velocity. So the question wants me to find acceleration. So acceleration, A equals dv by dt. So we're going to differentiate V. So V was 20 minus 60 squared. Let's differentiate 20 is 0. Minus 60 squared is minus 12t. I differentiate 2kt will be just 2k. K was root 15. So anyway, so plus 2k j. And k is root 15. 2k tj. 2k tj. Is it 2k tj? We differentiate, no, it's just 2k. It's just 2k. Yeah, it's just 2k. I bet. What am I thinking? So A equals minus 12ti plus k is root 15, so 2 root 15j. When t equals root 10 over 3, A equals to minus 12 times root 10 over 3i plus 2 root 15j. So yeah, so you get A equals to negative 4 root 30i plus 2 root 15j. Oops, not that way. Wrong bracket. Plus 2 root 15j meter per second squared. So, well, in a nutshell, if you need velocity, UV equal. If you need acceleration, A equals. Okay. Right, next one. A particle, P is moving in a plane. At time t seconds, the velocity v is given by that. When t greater than 0. Again, when you see an equation with a function of t, you know it's something to do with integration differentiation. Because if you try to use root ut, as in setting up the r equals ut plus half at squared, or v equals u plus at, that kind of Suvat formula, this is not going to work, because those only work when when acceleration is a constant, but in here it is not clearly. Next one, when t equals 0, the position vector of p with respect to a fixed origin is 2i minus 3j. So this here, it means, if we simplify down to a maths equation, means when t equals 0, r equals 2i minus 3j. Find a position vector of p at time t seconds. So if I want to find the position vector, when we're given velocity, to find position vector, r equals integral v dt. So let's integrate that. So let's integrate the 3t on the I. That's 3t squared over 2i plus integrate half t squared. So add 1 to the power, divide by that. So it'll be 1/6 of t cubed j. And now forgotten child c. Now we're told when t is 0, r is 2i minus 3j. Let's sub it in. So 2i minus 3j on the left hand side. On the right hand side, t is 0, so 3 times 0 over 2i plus a 6 times 0j plus c. That's 0, that's 0. So c equals 2i minus 3j. So if you remember from normal differentiation, integration, once you find the value of c, you sub it into original. So r equals, so where's original? Well, yeah. So r equal 3t squared over 2i plus 1 over 6t cubed j plus 2i minus 3j. Well, I need to simplify the i's. Okay, there are two i's in there and 2 j's in there. We can't go for I. Okay, so all we can do is combine the i's together. So it's like factorizing, really. So 3t squared over 2 plus 2i plus a bracket 1/6t cubed minus 3j. And that's the position vector. And that's it. All right, so this example is just a easy one to show you how do we use the value of c when it comes to I and j. It's the same thing. Okay, the c instead of a number, you just have I and j. Let's look at the next one, a little bit more complicated. Next one, velocity is given by this. A bit more challenging. When t equals 0, the position vector of p is this. So again, this whole line could simply be replaced with one equation. When t is 0, r equals 2i minus 4j. That's the information we need. Next one, part A, find a particle, find a position vector. So find a position vector means r equal, I'm given v, so r equals v dt. Integral v dt, let's integrate that. So r equal 3t cubed over 3 minus 8ti plus 5tj plus our beloved child. Simplify that. 3 over 3 cancel out. I'm told when t equals 0, r equals to 2i minus 4j. So 2i minus 4j sub into r equals to 0 cubed minus 8 times 0, I plus 5 times 0, j plus c. 0 minus 0 is gone, 5 times 0 is gone, so c is 2i minus 4j. Rewrite the whole thing, so r equal t cubed minus 8t. Now, if you imagine c becomes 2i plus minus 4j, I'm going to put a 2 into the I as well. I'm going to group the 2 into the I. Plus 5t and group the minus 4 into the j. And that will be the position vector. All right. So, or in case you can't, I'm just going to write, I forgot to write the intermediate step. You can write basically as t cubed minus 8t I plus 5tj plus our c value 2i minus 4j. But what I've done is I've just put 2i into here and minus 4j into there. Right? So hopefully it's clear enough. Next one, part B. Okay. another information in there. A second particle Q moves with constant velocity, AI plus 4J. Oh, constant velocity. When we see this word combined with vectors, what do you remember? This is a very, very special word. I have mentioned so many times in 8.1. When you say what constant velocity vectors, the formula comes into play. R equals R naught plus Vt. When time equals 0, the position vector of time is given to that one, just 2i. So it means when t equals 0, R equals 2i. Right, so you are thinking, sir, did you not say we are not using mover in here because the acceleration is not constant in part A? Did you not say when we say t squared, we use calculus? Yes, but this particle Q is not. P is moving with variable acceleration, but Q is not. How do I know? Because of the word constant acceleration. When you say constant acceleration, a constant velocity, so constant velocity, R equals R naught plus Vt. Right? So prove that P and Q collide. When they collide, which variable we're talking about? R, B, or A? Well, when they collide, that means they have to be in the same position. Right? So when they collide, part B. So that's it. Okay, so when they collide, so P and Q collide, it means the position vector of P equals position vector of Q. We've got a position vector from P already, which is from part A in here. So that's given. So that's sort of given as in you've worked out. So next, we're going to find a position vector of Q. So PV of Q, as I said, if you remember what I said, you need to use R equals R naught plus Vt. Things become a lot more straightforward. R equals R naught is the initial position vector, which is 2i. So 2i plus velocity, constant velocity, 8i plus 4j times t. So R equals 2 plus 8t I plus 4tj. So what I've done is I expand the bracket and put the i's together. I was told they're the same. PV of P equals PV of Q. So PV of P, let me write that in column. So t cubed minus 8t plus 2 and 5t minus 4 equals PV of Q, 2 plus 8t and 4t. So that's the PV position vector of P, and that's the PV of Q. What's next? We can equate the top, make one equation, and equate the bottom, and form another equation. So t cubed minus 8t plus 2 equals 2 plus 8t. We also have 5t minus 4 equals 4t. Well, I'll simplify that. Left-hand side, so you can see it's t cubed minus 16t plus 4. No, there's no plus 4, silly mistake. And then t cubed minus 16t, we can factor t out. So t squared minus 16 equals 0. So t equals 0, or t squared minus 16 equals 0. Put a 16 over, so you get 4 or minus 4. You can't have a negative time, so t is 4. Right-hand side, simplify the simple equation, t equals 4. You can't believe how simple that equation is. We're talking about year 13 maths. So t equals 4. Therefore, P and Q collide because we found the same time that they appear in the same position. When do they collide? When time equals 4 seconds. And that's the answer. Right. Well, how do you know if they don't collide? If the time they don't have they don't have the same time, then they don't collide. That's how you show they're not colliding. If they're not colliding, you still work the same way, but you don't find the same value of t. Okay. And pleased to tell you, this is the end of mechanics.